In this video, I'm going to show you how to simplify logarithmic expressions using 4 examples. But before we get into it, let us review what are the properties of logarithms. These are the properties of logarithms. The first one is the product property. So if you have a log of base b of a product, in this case x times y, then you could break it up into multiple pieces. So you have the log of the same base b of x plus log base of the same base y. Similarly, we have the quotient property. If you have a log of a quotient, then you could once again break it up into multiple pieces, but this time it is separated by a minus. Then we have the power property. If you have a log containing something with a power, so in this case x to the power of y, you could take whatever's in the exponent and move it in front of the log. So it is the exponent times the log. Then we have the case where whatever's inside of the log matches the base. So in this case, we have log base b of b, and this is equal to 1. And if you have a log of whatever base of 1, then that is equal to 0. And these can be proven if you look at the inverse or the exponent. The last one is the change of base formula, but this isn't really relevant to this video, so I'm not going to go in depth about it, but this is what it is. Let's take a look at my first example. I have log base 2 of 4k squared x cubed. I can immediately take notice of the fact that I have a product inside of my log. I have 4 times k squared times x cubed. So I can break this up into 3 logs. So now I could rewrite this as log base 2 of 4 plus log base 2 of k squared plus log base 2 of x cubed. So this is my first step. I know I could simplify this further because I have exponents in these 2 pieces, but I could also have an exponent in this first piece over here with just a little bit of manipulation. 4 can be rewritten as 2 to the power of 2. So this becomes log base 2 of 2 to the power of 2. And then let us actually go take these exponents and move them up front. The square from the k and the cube from the x. So plus 2 log base 2k plus 3 log base 2 of x. Now, because of this little manipulation over here, the fact that I've turned this 4 into 2 squared, I can move the 2 up front. So this 2 goes up in front of the log, but then I'm left with log base 2 of 2. And because what is inside of the log matches the base, I know that simplifies into 1. So I can immediately just rewrite this as 2, because that's technically 2 times 1. So that's 2 plus 2 log base 2 of k, because I can simplify that further, plus 3 log base 2 of x, again because I cannot simplify these 2 further. This is the most simplified version of what I started with. Now for the next example, I have log of base 2 again, but this time I have the square root of x over y squared. I do have multiple pieces inside of my log, except it's not a product, or technically you could see it as a product, but let's use the quotient property to figure this out, to simplify this. So because I have a quotient, I'm going to break this up but separate them by a minus. So this becomes log base 2 of the square root of x minus log base 2 of y squared. Another way you could look at this as a product, using the product property, is the fact that y squared is in the denominator, so you could rewrite that as the square root of x times y to the power of negative 2. And then with some manipulation, you'll end up with the same simplified answer. But let's keep going using that quotient property. So now that we've separated these 2 pieces, we can see that both of them contain exponents, one more obvious than the other. The square root of x can be rewritten as log base 2 of x to the power of 1/2. Now I can more obviously see that exponent and move it up front. And then for the y, I'm going to take that square up front. So I move what's up there into the front of the logs. I have 2 log base 2 of y, and then doing the same thing for that square root of x, I have 1/2 log base 2 of x, and then I cannot simplify that second term any further, so I'll just keep it as 2 log base 2 of y, and then this is the most simplified version of what I started with. Now for this example, you have log base 5 of x squared divided by x minus 4 to the power of 4. This one might seem a little more complicated, but let's do this by steps. So I can immediately see that I have a quotient, so let us apply the quotient property. So let's break this up into two pieces. So I have log base 5 of x squared minus log base 5 of x minus 4 to the power of 4. Now I see that I have exponents in both of my terms, so I could take these out. So I'll take this 2 up front, and then this 4 goes up front, so I have 2 log base 5 of x minus 4 log base 5 of x minus 4. Now you might be tempted to do something about what's inside here, but this is not a product, nor is it a quotient, so you cannot separate this log into two pieces. So this is the most simplified version of what I started with. Now our last example might seem complicated, but it's not that bad if you look at it in steps. So first I have that square root, and that is preventing me from breaking this quotient up. So what do? As you can recall from the previous example, if I have a square root, I can rewrite this, and this becomes the natural log of whatever I have in there, so it's 2x plus 6 over x plus 1 to the power of 5, and the square root is rewritten as the power of 1/2. So now it's pretty obvious what I should do, and that's move this power up front. So I have 1/2 the natural log of whatever's inside, 2x plus 6 over x plus 1 to the power of 5. So now there's nothing preventing me from breaking this up into, or using the quotient property to break this natural log up. And a reminder, the natural log is just log base e. It's just a fancy way of writing it. So this becomes 1/2. You could think of this in two ways, or not really. Or you can just factor out the 1/2, and you have log of the numerator 2x plus 6 minus natural log of x plus 1 to the power of 5. The main point is that 1/2 is multiplied by both of the pieces that are being separated. So you could write it like this, or you could write it as 1/2 natural log of 2x plus 6 minus 1/2. So all I'm doing is just distributing that 1/2 to the two things that I have inside of my parentheses. So now my first term cannot be simplified further, and the second term, I do have something that I could simplify. I could move this power up front. So I have, keep the first term the same, 1/2 log 2x plus, that's not it, 2x plus 6 minus 5/2 natural log of x plus 1. And that's it.